All right, so these are notes on solutions. These are for people who want more than an average level of challenge. So if you normally do the extensions, or you want to challenge yourself with higher level vocabulary and deeper concepts, you would do this one. If that's not for you, you want the regular 7th grade concepts, then you need to stop this video right now and go to the other video. All right, so let's first look quickly again at how we categorize matter. And I'm going to go through this kind of quickly because, again, I assume this is for the people who want a higher than average level of challenge. So we know we have all matter, and then we have all energy. And so everything can either be categorized as matter or energy. In these notes, and in fact in all of mixtures, we're focusing solely on matter. And now we know matter can be categorized into pure and mixtures. On the pure side of things, we can have pure elements such as sulfur, that's on the periodic table. It's one of the elements we heated in our temperature unit. It was yellow, it turned kind of liquidy. We actually melted the sulfur, and then it refroze when it cooled. It gave off kind of a rotten egg smell. So that's sulfur, that's a pure element. It's only sulfur. And we can also have pure compounds like salt or baking soda. So salt is, scientifically, it's called sodium chloride. That's sodium and chlorine. They're both on the periodic table, and they are connected. They're bonded together like Legos, as we've been saying. But we can also start just saying they're bonded, the sodium and the chlorine. The baking soda is the same way. That's actually a bond between 4 different elements. It's sodium, hydrogen, carbon, and oxygen. But again, they're bonded together, and you can't separate them. On the mixture side of things, we have 2 different kinds of mixtures. We have solutions, and solutions are mixtures where you cannot see the different parts of the mixture. Okay, so in this example of water with blue food dye in it, you can't see the blue food dye as different from the water. Then we also have what are called heterogeneous mixtures. So heterogeneous mixtures, heterogeneous means different parts. So here you can see the different parts. This is sand in water, and you can see the water and you can see the sand, and so that's called a heterogeneous mixture. And a lot of mixtures are sort of somewhere in between. They're not just a solution or a heterogeneous mixture. They're sort of a gray area for a lot of them. We're not going to worry about those gray areas. Not a big deal. So as we said, a mixture where you can't see the different parts is called a solution. And I want to give you some vocabulary that goes with that. So here I have a substance, and it's, we're going to say this is a thing of water. The blue part is the water, and the white part is sugar that's dissolved in the water. Now, we just said that a solution, you can't see the different parts, but in order to show you this, I had to color the sugar white. Obviously, if you mix sugar into water, you're not going to see it. So there are 2 parts of a solution. There's the solvent, and that's the thing there's the most of. And then there's a solute, and that's everything else. So take a second and define which part of this sugar water is the solvent and which is the solute. So you should have gotten that the water was the solvent, because there's the most of that, and then the sugar is the solute, because that's everything else. Now I could dissolve something else in here. I could dissolve, say, particles of salt. Let's say these red things are particles of salt. Then I would have 2 solutes. I would have sugar and salt, and that's fine. You can have lots of different solutes. There's only one solvent, because the solvent is the thing there is the most of. We also have these terms unsaturated and saturated. So unsaturated is where you can still dissolve more solute. So if I can still add more sugar and it still dissolves, then that solution is unsaturated. But if it gets to a point where I can't dissolve anymore and it starts to kind of collect on the bottom, this happens a lot with like when you're making hot cocoa, when you get to the bottom of the cup and there's all that like undissolved powder, that's because your solution was saturated. You can't dissolve anymore. There's literally no more space between the particles of solvent for solute to dissolve. Remember, we talked about what's between particles of stuff, and we said nothing. Well, that's how you can dissolve things, because as you dissolve, it fills up the space, but at some point there just is no more space. One thing I want to say that's not on here is that solutions don't have to be liquid. So you could have gaseous solutions, so the air around us is a gas solution, where nitrogen is the solvent. Air is 90 or 80% nitrogen, and everything else, the oxygen, the argon, the carbon dioxide, any water that's in the air, those are all solutes. Something like bronze, like we saw in the video, is also a solution, because you can't see the tin and the copper as separate, but that's a solid solution. So we often think of solutions as being liquid, but they don't have to be. They can be solid or gas. So, whoops, I realized I didn't put these images in to come up later, but we won't worry about them for right now. Solutions then can actually be divided into electrolytic solutions and non-electrolytic solutions. So it has to do with whether the solute forms electrolytes or non-electrolytes. So this says electrolytes and it's really electrolytic and non-electrolytic, but the solute then forms electrolytes or non-electrolytes. And what happens is this determines, for example, whether the solution will be able to conduct electricity. So pure water itself does not conduct electricity, and just kind of remember that, because we're going to come back to that idea, because then we're going to dissolve these things in pure water. So electrolytes conduct electricity because they are compounds that separate into positive and negative charges. So this picture here, now we know what this is. This picture here is a picture of salt. So these little particles, the little red ones, are the sodium, and the big yellow ones are the chlorine, and the sodiums are positive. Let's put a positive there, and the chlorines are negative. And so when they dissolve, the positive sodiums, so here the positive sodiums, separate from the negative chlorines. And if you've ever looked at a battery, you know it has a positive and a negative side. That means it can conduct electricity. So a charge can be conducted from the positive to the negative here. And that's why something like salt water does conduct electricity. That's why I was told to get out of like lakes and oceans and stuff if there's lightning. If it were actually pure water doesn't conduct much electricity. But when you dissolve stuff in the water that's electrolytic, that forms electrolytes, then it does conduct electricity. So let's contrast that to non-electrolytic solutions or non-electrolytes. They do not conduct electricity because those compounds do not separate into charges. So here I have a picture of the glucose molecule. So if you care, that's 6 carbons, 12 hydrogens, and 6 oxygens. And glucose is one of the main molecules that our body breaks down in order for us to get energy to do everything, to write notes and to breathe and for our cells to divide. So it's a really important molecule. But when glucose dissolves, it doesn't separate out. So this was my attempt at like, here's a big thing of water and here's the little glucose is dissolved, and they're separate from one another. And so it would be a solution and you can't see them. They're so finely mixed you can't see them, but they haven't divided up into any positives and negatives. So they wouldn't conduct electricity. So regular sugar also is non-electrolytic. So like if you had a thing of sugar water that you were swimming in, that also wouldn't conduct electricity. All right, please feel free to ask questions if you're confused about these concepts. Have a good day.